Okay, so we are back again, and you remember sometimes after creating your table or your tree, you'll be asked to find different probabilities from those from your table or your tree. So in this case, we'll be finding the probability that Alicia is actually sick, given that she tested positive. And the first thing required of you is to write this in notation. So you can see here that this given means that it's condition on something. So you know that Alicia is sick given that she tested positive. And our positive was denoted by what? Event A, and being sick, which is having a disease, is denoted by event B. So this will be what in notation, this will be the probability of B given A, which is being sick given that you tested positive, or given that Alicia tested positive. So now, what do you think of? You think of how to get these conditional probabilities. So the first thing to think about is you want to use this table. What is the total number of people who were actually sick and actually tested positive? So from this table, we saw that there are 95 of them. And now this is conditioned on what? People who tested positive, which is this guy A. And now we'll divide what? 95 by 50, 90. And that will leave us with 0.01866. So that's the probability of Alicia being sick, given that she tested positive. And we can also use the tree to find this probability. And using the tree involves a little bit of math using what you know. And what you know is basically you have to first state your notation, and also you can rewrite this probability of B given A using the given rule or the conditional rule, and this can be rewritten as the probability of A and B divided by the probability of A, because remember B is conditioned on A. So this probability will divide this probability. And now from this tree, you can see that we can easily find the probability of A and B, which is right up here. But we can easily find the probability of A. It's not anywhere here. But we can use one of the rules that we know, which is finding the probability of A. You can add the probability of A and B and the probability of A and B complement. So probability of A and B and probability of A and B complement can be found from these guys. So you can see probability of A and B here and the probability of A and B complement here. So you can add these two probabilities and they will give you the probability of A. So once you know that, you can now go ahead and divide the two of them to find the probability of B given A. And by doing so, you will get the same answer as we did when we used the table. And lastly, from the worksheet, you are asked to explain what the probability means, but do not use the word probability in your explanation. So you know the probability of B given A gave you this guy. So what do you know? First, look at this notation and look at what the prompt asks you to find, which is the probability of Alicia is actually sick, given that she tested positive. So what this probability means, remember probability is in terms of what? Is a random process which is repeated over and over and will give you a particular, when repeated over and over, will give you a particular outcome. So what it simply means is in a very large number of people who test positive, only about 1% of the people actually have the disease.